Logarithms in base 10 are also called common logarithms. Common logs. Um, Now, when a logarithm is written without a base, like this, log 5, it doesn't mean that that log does not have a base. Of course, it has to have a base. This means that the base is 10. Your calculator can actually work out logs to base 10, and I'll show you how that works. So you can, for example, work out log to base 10 of 10. So log to base 10 of 10, which will be 1. Log to base 10 of 100 is 2. Remember here we're ignoring the base. You're just writing it as log 100. But that actually means log to base 10 of 100. And of course, log to base 10 of 1,000 will be 3. So we can generalize these results here and say log to base 10 of 10 is 1, which is just be log 10, which is 1. Log to base 10 of 100 will be log 100, which is 2. Log to base 10 of 1,000 will be log 1,000, which is 3. So, in fact, we can generalize and say log to base 10 of 10 to power any power, for example, 10 to power x, will just be x. Because remember here, that's 10 to power 1, 10 to power 2, 2, 10 to power 3, 3. So 10 to power x is just x. That's very important. I'll also look at something else. We're still on logs, common logarithms. Now, if y is equals to 10 to power x, then if we convert this, this is exponential form. This is exponential form. So if we convert this exponential form to logarithmic form, we'll end up with x will be equal to log to base 10 of y. Now this is logarithmic form. And we can write this as log y. So which means that this guy here actually this guy here, y can be written as 10 to the power of, we know that it's 10 to power x, but we can write that as 10 to power whatever x is. We know that x is this guy, so log y. So we are saying y is equals to 10 to power log y, where y is any number that's greater than 0. So we can say that and summarize this, or generalize it and say any arbitrary value a that's greater than 0 will be equal to 10 log a. That's very important. I'll show you something else. Log to base a. Now, log to base a, if y is equals to a to power x, whereby this is exponential form, um, then we can write that, then we can write this in exponential log form, logarithmic form. So we'll say x is equal to log to base a of y. So this is log form. Um, so, but we know that, so we are saying that um, x is equals to log to base a of y. But we know what y is. Y is a to power x. So we can write this as log to base a of a to power x. Um, that is an important relationship. So we'll say x is equal to log to base a of a to power x. I'll just write it somewhere there. That's very important. Alternatively, if x is equals to a to power y, then y will be equal to log to base a of x. Now remember, again, this is in exponential form. This is in log form. So then we can say that bringing these guys together, we can say that x is equal to a to power whatever y is, and y is log to base a of x. This is a very important result. So we say x is equals to a to power log to base a of x.